All right, AMP1 students, we're going to finish up chapter 1 with homeostasis. And we have a couple of more objectives down here at the bottom. We're going to it's kind of a summary, but talk about 5 characteristics that we have learned so far about the homeostatic systems in the body. And then we're going to talk about the relationship of maintaining homeostasis to health and disease. So I'm going to flip to our textbook here. So when it comes to homeostasis, they've kind of picked out 5 characteristics that's important to remember. So they're listed here. The first one is that these homeostatic control systems are dynamic, meaning they're constantly changing. They're not, always the same. So we have constant changes going on, and they're always working to keep things in the normal range because we have a lot of environmental changes going around either inside our body or outside of our body that require our homeostatic control systems to kind of constantly be on their toes trying to keep up with all the changes going on so that they can keep our parameters like heart rate and sugar in our blood and body temperature in the normal range or near set point. The other one is the control center is generally the nervous system or the endocrine system. So we discussed that earlier. Also the 3 components that we've discussed quite a bit is receptor, control center, and effector. And then we talked about this when we did negative versus positive feedback. The negative feedback is the more abundant type of homeostatic control system in the body. So most of our homeostasis is where we have a parameter that's at a certain set point or in a normal range, and most of our homeostatic control systems are keeping it in that normal range, so they're considered negative feedback. And then we talked about this early on when we talked about the purpose of homeostasis. If we don't maintain these certain parameters within their normal range or near their set point, then our cells suffer and they don't get what they need, and then they can't function properly. So that leads to illness, sickness, disease, and ultimately if we can't get it back in balance with surgery or medicine, changes like that, then death can follow. So all right, so just a little review there, which is good. And the other objective, we kind of already talked about it, but just explain the general relationship of maintaining homeostasis to health and disease. So again, if our body can't maintain homeostasis, then we will have our health will be adversely affected, and we can be ill and even die from that too. So, all right, so they gave it some examples. So I'll talk about a few of them and maybe some of my own. So an example of a homeostatic imbalance that most people are pretty familiar with this disease, diabetes. It's called diabetes mellitus. And most people know it's a problem with people's blood sugar. So remember we said blood sugar was one of those parameters that we need to keep within a normal range or at a set point in the blood. We need a certain amount. So that way our cells have the energy they need to do what they need to do. So people that so there's a nice homeostatic control mechanism. It's a negative feedback one that keeps the blood sugar in that normal range so that our cells get enough sugar and they can produce energy and they can function properly. So, but some people have a disease that can cause that homeostatic control system not to work. And so when that happens, then they can't keep their blood sugar, and generally it goes higher most of the time. Goes too high, and that can affect all the organs in the body because the glucose is in the blood and the blood goes everywhere. So it can cause problems with all the organs within the body and damage them. So patients that have that problem, they need help maintaining their balance of glucose in their blood. So they may, do something to change their diet. They may use medications. They may start like a exercise routine, something like that, to try to help that. Whereas people that don't have a problem with with maintaining their blood sugar. I mean, I can go and drink a whole milkshake and, and it'll be, or a whole bag of candy, and I know that my body will respond to that and not let my sugar get real high and stay really high, because I have a properly functioning negative feedback control system for my blood sugar. But people that don't have to work a little bit to keep their sugar in the normal range, so they don't have other problems with other parts of their body and have some serious illnesses and even death too if it's not regulated. So that's one example that probably most people know about that disease. So, okay, the other things that we'll talk about medications. So some people will have a disease that they'll need to take medications for. And so those medications, you have to be familiar with those medications and how they obviously affect the disease and how they're going to help that disease, but also how they might affect other homeostatic control systems in the body. So you guys are probably familiar with when you see advertisements for medications on TV, or you go to the pharmacist and they give you like they always send you with the paper about the drug that you're going to take. And if you look at side effects or adverse effects, or on the TV commercials, they'll go over, all this list of possible side effects with the medication. And sometimes it's like, man, I think my problem isn't as bad as all the side effects that are possible. Maybe I shouldn't take it. But those side effects are there because those medications, and you have to be aware of those and be able to manage those. But it's because the drugs work, for one part of the body for a particular disease process, and then they may work in another part of the body too. So the book gave an example of these serotonin reuptake inhibitors. So these are pretty, and most people are probably more familiar with the trade name Paxil, Prozac, Zoloft. So those are medications that will help people with depression, because it increases the amount of neurotransmitter. Serotonin is a transmitter. How much of that's in the brain between nerve cells, and so that's a good thing because that'll help with the depression. But you also have to realize that you could have some side effects because that serotonin is also present in the nerves that are sending signals to your digestive system too. So you may have some issues with your digestive system, not working properly, because again, it's interfering with that homeostatic control mechanism that's going on in the digestive system. So most of those things though kind of work there, you might have those side effects at the beginning, and then it kind of, after you're on the medication for a while, it kind of evens out a little bit. The homeostatic mechanisms kind of adapt to that. So that's another example. And so we'll talk about when we talk about diseases, I'll try to bring up that, this disease is happening because of this defect and then that defect or problem won't allow the homeostatic control system to proceed like it's supposed to. So, okay, so that is the end of chapter 1, the videos for chapter 1. So each of the videos has a knowledge check. So you can go and after you watch the videos, do the little knowledge check to make sure that you understood what you were listening to and taking, you got good notes and things like that. So it's kind of make sure you're following along and not getting lost. But if you have any problems, please let me know so I can answer your questions early on. It's best to, problems arise and you're not understanding something, get it taken care of earlier than later. So anatomy and physiology is one of those subjects, like most subjects, where what you learn at the beginning, the information beyond that just builds on what you learned at the beginning. So you really have to have a good understanding of this basic information early on, so that you'll be much more prepared for the information later. So, okay, I will see you for chapter 2.